Hello, and it's a warm welcome here on your first agricultural TV station, the Agricultural Research Council of Nigerian Television, and the program is Aqua Farming. My name is Joshua Ishai, a regular host. Anytime you see this face on your TV screen, you already know it's that time of the day where we need to understudy those potentials that are in the water, and especially crab, frogs, fish, and all amphibian edible animals, or rather organisms, is what we discuss here. And today on the program, we'll be looking at something quite interesting. We'll be talking about snails. We'll be looking at the socio-economic importance of snails. There is no known date when man started consuming snails. The consumption of snail meat transcends back in prehistoric times. Snails are invertebrate animals that belong to a group called mollusks. Other numbers are squids, mussels, cuttlefish, and slugs. Snails are reared as a source of food for their medicinal properties as well as for their artistic value. Meat, caviar, and snail secretion are the main product of snail farming. Climate, feeding, hygiene, and other ethic factors are key to successful snail farming. Snails can be bred in indoor farms, open air farms, or garden farms, in intensive or semi-intensive systems. Snails are vegetarian but will not consume hairy vegetables, leaves, or those that produce toxins such as physic north. Young snails feed on tender plant material and consume twice as much as their mature counterparts due to the differences in surface area to volume ratio. As snails age, they feed humus, dead leaves, and rotten fruits. The size and age in which snails are harvested depends on the breeding objectives. However, it is recommended that snails be harvested before attaining 24 months because after these milestones, growth gradually retards. Snails are commonly reared for domestic or commercial purposes in Europe, North America, and parts of Africa, especially Nigeria. Sit back and take a look on this interesting topic of socio-economic importance of snail.
To ensure adequate monitoring and maintenance of good record keeping, breeders may be raised in tiered cages from where the seedlings are transferred into the paddock units. The baby snails are stocked and managed at a high density within the paddock for the first 2 months. Thereafter, they are divided and transferred into 2 or 3 other pasture units at a moderate density for the next 2 months. Finally, the snails are managed in a third set of pens at a lower density till when being harvested. Each unit is replanted, managed immediately as stock is transferred in preparation for the best batch snails. This is termed stage management and it makes record keeping more appropriate and the units maximized. Alternative, the hatchlings may be transferred from the cages into the prepared units at low densities and raised till they are ready for sales. Snails, depending on the rate of growth and multiplication, size at maturity, and method of paddock management, should be stocked at a rate that ensures that the plants are not quickly depleted but maintained to sustain the stock growth for a desired period. A regular complementary concentrate may be provided at alternate days to cater for vitamins, mineral, and amino acid deficiencies. However, supplementary feed using concentrate, waste fruits, and edible leaves from markets or other cheaper means may be served when the vegetation can no longer support them. Identified challenges associated with open paddock system and probable solutions. The main challenges associated with this system of farming are those of snail population management, insect management, weed management. Snail population management. This may pose a big but good challenge, especially when a fulica is farmed. The snail starts laying at an early age when the size and meat texture are unacceptable in African markets. Thus, it becomes difficult controlling its population and the practice. A good option is to culture the animal till the desired snail size is attained and then sold. Thereafter, quality snail seedlings produced within the units are selected and transferred to another rearing pen, while the rest are harvested and processed into animal feed material or other byproducts if there is no room for expansion. The unit is then prepared for the next set to be found. Insect management. Insect management in paddock farming may not be an easy task, especially when the challenging insects can fly or burrow into the soil. Flying insects can hop in and out of an open paddock and poorly netted closed paddock. They lay eggs and develop fast within outside the pen, thus making it more difficult to manage. Assuming the option of roof netting and chemical application are ruled out, the farmer may possibly harvest these insects periodically, heat dry them, and mill into powdered form to feed the farmed snails. This is achievable with the use of insect harvest, a mini machine that attracts ants at night time by means of a bright light and a spinning blade that knocks them out. This option is considered as being advantageous in increasing the snail's productivity. Prior to stocking, this challenge may be handled by spraying the edible leaves to poison the insects. Once controlled, the plants are thoroughly irrigated for a space of about 3 weeks before stocking. Burrowing insects such as soldier ants, once found within the rearing pen, may be managed by wetting each paddock unit until being waterlogged. In dwelling snails, such first be salvaged into another pen before the treatment commences. An appropriate chemical or hot water treatment may then be applied on the insects, now forced out of their hidings within the pen. However, preventive measures such as maintaining a cleared zone round the pen, burning of slashed dried weeds on site, proper spraying of the vicinity before and after plowing, and building of water oil trench barrier around the pen should be helpful before stocking. Weed management. Weed control is essential during production. Ensuring proper removal of weeds prior to stocking is the first step towards weed control. Planting of choice plants should be done immediately after weeding to favor their growth. Keeping the plants densely packed and maintaining different canopies of plants also helps in minimizing the growth of weeds. When weeds emerge within the pen, they may or may not be removed depending on the type, effect on cultural plants, and rate of spread. If weeds are sparingly sited, they may be left to provide shelter and serve as additional feed materials for the bred snails. Periodically, tough and fibrous weeds such as pear grass should be removed manually, while soft and tender, tasty weeds should with patches of eaten leaves should be retained, except when hindering other choice plants' growth. Intra and interpaddock paths may be managed of weeds by simply installing concentrate slabs or the weeds are manually cleared. Snailery inspection. Frequent inspection of farmed snails is encouraged to determine how active and well managed the snails are. Thorough snailery inspection should be carried out once a week, though mild inspection should be handled along with routine feeding and snailery hygiene. With good source of illumination, snails should be inspected when they are active and feeding, especially at night. When inspecting a snarry, the following parameters should be taken into consideration once the obstructing feed and debris have been lifted. How active the snails are in terms of their movement, rates of feeding, that is, quantity of feed consumed within a given time, and presence or absence of snails with epigram over their aperture. When operating an intensive system of snail farming with separate egg incubator and hatchling cages, sighting an egg or hatchling search should suggest a search for other eggs or hatchlings. The expected egg output should be looked out for within a radius of 5 meters from those found. Aberrations in egg coloration, size, texture, and shape should be recorded. Number of dead snails noticed should be recorded on weekly basis. If the figure is high, a daily record might be needed in determining the severity of the condition. The age groups affected and those affected most should be noted. Strange body marks such as bites, sites, or other lesions must be noted with the sites affected. The shape, size, appearance, and color should be described. Presence of pests and predators should be recorded. The type, prevalence, and location of such agents should also be highlighted. Sighting of insect larvae, ants, tiny insects, and other pests on snails and or in pen soil may serve as a good indicator in determining when to retreat the soil and bath the snails. Snail cannibalism and odd feeding, when observed, should be recorded and necessary steps taken to correct the situation. The obtained data may be utilized in ensuring that reared snails are kept in a good state of health. Data collection and record keeping. This is the gathering and compiling of useful information for future use. Data collection and record keeping are useful tools in studying the performance of snails and the contributing role of their environment in order to increase their productivity. Keeping record of events should be helpful in improving those outstanding traits in a stock. Snails with records of superior qualities may be selected from an old stock as the breeder stock, while the rest of the old stock is sold out. Such selected traits may be geared toward meat or egg production. Record keeping also helps in disease monitoring and surveillance. This means that through record keeping, the health and disease status of snails may be studied to prevent or control the factors that brings about such instances. Such a record may be a vital tool in the hand of a specialist in determining what advice to give in increasing productivity, managing a disease cage, preventing the reoccurrence of a disease condition, and so on. Considering these facts, it becomes obvious that necessary production data should be collected and stored in a file or in a retrievable system. Data of interest that should be gathered when visiting your snarry are deliberated upon below. Traits that are associated with improved reproductive performance should be noted. A relatively high number of eggs laid in a cluster suggests that snail that laid the eggs has a good breeding quality. The number of eggs laid should be recorded, picked, and incubated separately for breeding purposes. The eggs are picked because it is difficult to identify the snail that laid them, and the resulting hatchlings are expected to exhibit the traits. The rate of growth of age-mate snails that are raised together in terms of increase in body weight per unit time may be randomly taken and documented. The optimum sizes and weights at which the various species should be sold, and the frequency with which this should be done may be deducted from the obtained record. This will also be needed in determining the selling price per kilogram, whole weight or dressed weight. Likewise, selection may be made from the available data to favor meat production. Record of performance of specific snail types with regards to meat and egg production rates, adaptability to that environment, disease resistance, and the likes should be gathered and compared with each other in order to determine which species or subspecies is worth investing on in that locality. The number of snails within a given snailery may be counted on monthly basis in their various age groups to determine their production rate. Keeping of such record will be helpful in writing an appropriate feasibility study and to be able to project better into the future. From the book of records, farmers should be able to postulate on the number of cages to be constructed, the expected increase in feeding rate, the number of snails to be sold and how frequent this should be done, the expected number of snails in each age group after harvest, and so on within a year. Also, cases of mismanagement or disease condition may possibly be detected when comparing record figures. The number of dead snails should be recorded on weekly basis, except in a case of an outbreak of disease condition wherein record keeping should be on daily basis. The record should reflect the number of hatchlings, young snails, and adult snails affected. In case of a suspected disease condition, the morbidity and mortality rates and percentage morbidity mortality for various age groups should be estimated to determine the severity of the case. Morbidity rate, number of affected snails, period of time. Mortality rate, number of dead snails, period of time. Percent morbidity, number of affected snails and 100% total snail population. Mortality, number of dead snails times 100% total snail population. The above determined parameters, when combined with other clinical signs, should present a clear picture of the case and possibly indicate the age group to be cared for most and or treated first, being the most affected. Records on how such previous outbreaks were handled may give a good clue to what should be done. Random sampling of pen soil for possible pests build-up should be carried out on monthly basis, although such pests should be watched out for when carrying out normal routine work. The focus is to study the trend of growth of snailry pests and the peculiar pests often encouraged so that the right control measure may be embarked upon. It also helps in determining how frequent pen soil should be heat treated or effectiveness of such treatment on those pests. That is how thermo resistant the pests are. Fecal material is an important tool that is normally used in determining the gastrointestinal. Fecal material is an important tool that is normally used in determining the gastrointestinal parasites and flora of snails. The rate of increase or decrease of these intestinal parasites or flora on monthly or bi-monthly basis when carried out simultaneously with soil sampling gives a clear picture of the relationship between the gastrointestinal agents and the pen soil microbes, citing a significant number of fecal protozoan, cysts, and organisms in both gastrointestinal traits and the pen soil or in either of the two may suggest the treatment of choice for both or either of the two media and soil. Since the possibility of larval migration in heavily infested snails with helminth parasites or in a weak snail is apparent, records from regular fecal sampling may be found useful in determining when to deworm them. These results may also be useful in determining the appropriate sanitary practice to adopt. With the use of a hand lens, records of body parasite may also be gathered on monthly basis. The gathered facts may then be documented as low, moderate, or severe body parasite infestation. From the record, the rate of increase and possible effects of such body pests may be determined and the needed preventive or control measure worked on. The combined fecal, body, and pen soil examination should be carried out on regular basis, preferably every month or at least once in every 3 months, depending on the farmer's convenience. From such records, various cited pests and their activities may be monitored and checked. Records of weather factors such as temperature, humidity, and wind speed, direction, and the elicited reactions needed by penciled and studied. Records of weather factors such as temperature, humidity, and wind speed, direction, and the elicited reactions need be penciled and studied. This will be useful in pen designing and in determining a suitable method of management. Instruments such as thermometer, hygrometer, and wind vane may thus be needed. In addition to its assisting in stock selection and species improvement, these data will help the veterinarian or expert in actualizing an effective control measure to posed problems or in determining what preventive measures to suggest to prevent such occurrence. Record keeping likewise keeps the farmer informed on his products' progressive growth, thus building his confidence on the business with time. Pen identity equals pen number plus layer number. EC equals number of egg clutches. SE number of snail eggs picked. HI number of hatchlings picked. MRT mortality. Observations should include changes in eggshell color or texture. Description of lessons on dead or live snail and the ages or groups affected most, weather changes, change of feed or feed composition, changes in livability, presence of snails with epigram and the number involved, presence of pests or predators and their description. Other useful comments. AEC, average number of eggs per clutch per week. TE, total number of eggs collected per week. TH, total number of hatchlings picked per week. Percentage hatchability per week. Percentage M, percentage mortality per week. AWG, average weight gained per week, bi-weekly or monthly. Management of snail eggs and hatchlings. African giant snails are egg-laying land animals. They normally dig up holes to bury their laid cluster of eggs as a means to incubate them. Also, snails are often seen hibernating during the day, being buried under the soil or in crevices. As a result, buried snails are sometimes dug out of soil and exposed to desiccation, especially when operating an intensive system where the stocking density is high. Since desiccated eggs are unproductive and egg hatchability is not expected to be less than 80%, egg management must be well handled to ensure maximum production and business profitability. Exposed snail eggs should be picked along with their buried counterparts once they are sighted. Obscuring intrasnary items such as leaves and shade providing objects should be lifted in order to have a good view of the pen's interior. Once an egg is sighted, other clutch should be sought for in most cases within a close range of about 5 cm radius. The expected number of eggs in a clutch depends on the snail size, parity, and species involved. For instance, a Chatina species should normally lay about 80 eggs and 400 eggs at once, while Achachatina marginata normally lays between 6 and 14 eggs. Once the eggs are sighted and picked, they should be dropped in a bowl of water to determine their viability. Fresh looking eggs that sink or partly float with less than a third of the shell above the water surface are considered viable and should be buried in an incubating box. Those that float on water with more than two-thirds of the shell above the water level and have dull off-white color should be discarded. Few of such eggs may be cracked open for clarity. The incubation box should be filled with sterilized soil or substrate to a depth of about 4 to 6 centimeters. The soil should always be kept moist and the temperature preferably maintained at or above 28 degrees centigrade to enhance good hatchability.
This is easily achieved by placing the box in a warm location in a closed garage. The box may be of any desired measurement, 0.5 m by 1 meter box, and the picked group of eggs are buried in straight lines. This box can accommodate 4 eggs clusters sideways by 8 egg clusters, thus a total of about 30 clusters of eggs.
Many thanks for staying through on your first agricultural TV station. The program has been Aqua Farming. We've been looking at the topic socio-economic importance of snail. Snail farming is attracting entrepreneurs globally. Snails are reared for their nutrition, artistic and medicinal values like we said earlier on. To optimize production and development of the industry, intensive research and development is necessary. It's more reason the program Aqua Farming is setting the blueprint for this venture. There is need for capacity building to the small scale and large scale farmers to optimize production, including provision of subsidies and necessary extension expertise, sustainable commercialization of the industry, building processing infrastructure, infrastructural and organizational planning at national and international level, and introduction of horticulture to the mainstream school education. With that, we come to the end of this episode of the program. My name remains Joshua Ishaya. Bye for now.